I think a lot of the problems that we have in terms of friction and how long it takes to get things done is because the manufacturing sector has been starved of resources and managed down to a very low margin operation. Guess what happens in low margin operations? They cut corners on technology and anything that isn't essential, so they don't modernize nearly as fast.
Thousands of companies show up to sell their technology to the U.S. Department of Defense each year. But so few will transition from proof of concept to true production across the valley of death. The select few who do, their stories are rarely told. Until now, I'm Noah Sheinbaum, and this is Crossing the Valley.
Misha Govshteyn is rebooting the arsenal of democracy, working to revitalize American manufacturing. Misha is the CEO of Macrofab, a Texas-based cloud manufacturing company that has a network of over 100 factories across the United States and Mexico. The company supplies defense contractors and helps them produce the goods they need quickly, inexpensively, at a higher quality and closer to home. He says they don't always know where their products end up, but they hear quite often they're on the front lines in places like Ukraine in the hands of special operators. In this episode, Misha and I discuss the state of American manufacturing, our defense industrial base, what happened to deplete it, and what we can do to build it back up. Enjoy.
All right. Well, thrilled to be joined today by Misha Govshteyn. Misha is the CEO of Macrofab, a Texas-based cloud manufacturing company that has a network of over 100 factories throughout North America and is right at the heart of re-envisioning and reinvigorating our defense manufacturing base. Misha, thank you so much for being with us today.
No, thanks for having me, Noah. I'm looking forward to our discussion.
Yeah. So, Misha, you about a year ago now, you were quoted in an article that very famously kind of proclaimed that the American defense industrial base was not ready for war. And I'm curious, about a year later, how are we doing? Is the defense industrial base ready for war today?
I think some of the predictions made in that article are becoming true. And I think some of the concerns about it are true. Now, thankfully, we're not at war. There are a lot of people that claim that we're involved in multiple conflicts out there. But at the end of the day, we're a supplier to a lot of nations out there. Unfortunately, a lot of the world is at war. This is as much of a planning and scaling exercise as anything else. I live in Houston, so I have some practical experience with plans that sometimes have to be put into action, especially when a hurricane hits. And this is one of those things where you think you have a plan and your disaster recovery plan is solid until you put it in action and then realize just because you have a binder full of steps doesn't mean the real world situation will unfold the way you expect. So we are unfortunately involved by proxy in a number of world conflicts. And I think we're watching the pressure of those conflicts that it imposes on our supply chain, and it's not responding well. We're certainly not scaling up well enough. I think from history lessons, we know that the Defense Industrial Act back in World War II was essential to scaling up heavy machinery production and pivoting that towards tanks and other weapons. That was then. This is now. A lot of those mechanisms are no longer viable necessarily. And I think we've seen two major stress tests. One was during COVID, when all supply chains were stress tested, and I think failed miserably, right? I think that was a very clear indication that what we have in place may be cost effective, but it's not at all resilient. It can't handle scale. It can't even handle a rebalancing. You can't move demand from one part of the system to another and have things respond gracefully. We're seeing a different stress test now in our system in the defense supply chain world, and it's also not responding gracefully. So I think there's a lot of work left to do. And I'm hoping that people that run the country are realizing how much more.
It's certainly a hot conversation. I know even in the last number of years, the momentum around onshoring manufacturing and being able to have, to identify supply chain vulnerabilities seems to have grown. When you talk about the state of our supply chain, and when you think about why we're failing these stress tests, COVID and the defense shocks that are taking place around the world, maybe we could do a little bit of a history lesson for our listeners, which is to say, how did we get here?
I think in all cases, when it relates to both supply chain at large and certainly supply chain for the defense industry, I think we're talking about multiple years of optimization, and in some cases, I would say calcification of the way we do things, right? And the overriding objective over the years has been decreasing costs and eliminating the number of suppliers. If you look at any mature commercial organization out there, they're very good at their supply chains. They have optimized them for cost. But what they've given up is resilience, because these supply chains are brittle. And I don't think it's dissimilar in a defense world. I think there's a lot of examples. And I think the Raytheon CEO coming out and saying, we really couldn't take China out of the supply chain. They're controlling 2,000 different breakpoints in our supply chain. So we can't just flip a switch and change it. That is endemic across all of our supply chains, because they're not built as resilient, fault tolerant systems. They can be easily, the internet is built that way. You can kill the internet in multiple segments and then it continues going. Our supply chains don't work this way. So that's an abstract answer, but I think a lot of the practical answer is it's a lot of optimization, a lot of consolidation between firms, and fewer suppliers until the entire system is too brittle and can't respond quickly.
Yeah, no, I think, you're alluding to kind of the Last Supper in this famous moment at the end of the Cold War as we move into this peace dividend, when the Secretary of Defense gathers the CEOs of these different large defense contractors and says, look, defense budgets are shrinking. We're not going to have the capital, the appropriations from Congress to be able to support this ecosystem as it has been. We're not going to tell you what to do, but if you want to live, you're going to have to consolidate, because there's not going to be enough to feed everybody. And so that kind of kicked off this period that only now, really only in the last 7 or so years, we're finally seeing the rhetoric change and reverse to saying, actually, okay, we've now narrowed the supply chain too much. Now we've got to go a bit broader. It's a little bit like what happens if Uber and Lyft consolidate the taxi market and you basically crowd out all these other providers, and then you only have two and they jack up prices and quality suffers and things like that. And so now we're seeing this kind of reopening of the market. And as firms come in and try to, whether it's weapons or software, whether it's hardware or software or different kinds of weapon systems, supply chains seem to be a breaking point. And so, Misha, let's bring Macrofab into that story. What's the opportunity that you all see, and why is this company needed at this moment?
I firmly believe that one of the answers that I think supply chain world and certainly the defense industry is missing is digitization of supply chains. And I think in a lot of walks of life, our world has been turned upside down. And, the favorite example I use is that really nobody uses travel agents anymore. And it's not that they were bad people. It's that it's just faster and gives you a lot more control to book anything you need, including flight tickets or hotel rooms by yourself. You have a lot more control over it. It is a very software-enabled market. It is driven by marketplaces that aggregate all the capacity out there, and you can tap into and do a search, figure out exactly what you need, and place an order very quickly. Nothing in the supply chain world works this way. Nothing is digitized. Nothing is fast. The end users, the consumers, can't easily just go source a new part or a new subassembly, a full new product easily. It's all negotiations and emails and phone calls that are required in order to put contracts in place. You can't really modernize this system without building technology. And that is a lot of what Macrofab is. We're essentially building a layer of infrastructure that takes multiple factories and all the capacity in those factories and makes it available to our customers. So we are the manufacturer of record. We are the one throat to choke. We're responsible for quality. We're responsible for all the delivery. We directly work with customers. We have engineering teams. When you work with us, our customers look at Macrofab and say, that's my manufacturing company. But under the hood, we're essentially a software technology platform that places jobs into a lot of factories, these 100 factories around North America. Not all of them are owned by us. And some of them are giant factories in Mexico and United States. Some of them are small factories all over United States and Canada. So what we help customers build is electronics. It's both sub-assemblies and finished products, but it's done through a radically different system where the same platform, Macrofab, in all cases, you can go be an engineer, upload a design to our platform, place an order in 15, 20 minutes without having talked to a salesperson, get a set of prototypes, but through the very same platform, start building this in thousands of units, hundreds of thousands of units. We have a customer we're building 1 million of units for, and that's unprecedented. That's something that nobody's ever done before. And the magic sauce behind it is the software that drives it all, because that's how we move those jobs from one small factory to multiple big factories as it scales up.
Really interesting concept, and the software-enabled manufacturing is kind of a hot topic right now. There's a number of plays kind of in that direction, and this idea of just making capacity available to folks, and especially even spare capacity or underutilized facilities makes a ton of sense. Misha, I'd love for you to talk a little bit about how that intersects with the defense market, because you have an interesting business model. In many cases, your end users are the warfighter, the men and women in uniform, and yet your business model is not, as straightforward as responding to a government RFP most of the time. So, I'd love for you to lay that out. How do you actually intersect with the defense mission?
We are in fact responding to government RFPs, because at the end of the day, we may be a very modern firm. We still have to work with traditional real world, and we have to work on a real world rules. Our objective is to make every customer interaction to be as natural as possible. So even if they're not natively digital, and we have customers that are directly plugged into our APIs, and they can place orders without ever having to talk to anybody. But we will work with customers wherever they are. In terms of our customer base, we have a lot of aerospace companies building products with us, a lot of defense products, but primarily from the lens of consumer and just general commercial companies adopting their products for the defense ecosystem. A lot of these are communication products, satellite products. There'll be a version of it that's built for consumers. There's a version of it that's also built for the military, because a lot of consumer products in some ways are exceptional at being mobile and lightweight and being readily be able to use in a battlefield, but they have different requirements. They got to get stress tested. They got to be leak proof. Some of the enclosures have to be unbreakable, right? And it's certainly not built for consumer grade electronics. So that is the level at which we're involved. With some customers, we build sub-assemblies. So if it needs to be a PCB assembly that goes into a drone or goes into an aerospace system, then we can build those. And in some cases, we build fully assembled products. But in terms of how the environment operates, it's certainly not ready for software first companies, nor does it necessarily seek them out, right? I haven't seen a scenario yet where part of the RFQ that we receive is the need to digitize those designs, have them be available online, accessible through APIs. That's not a requirement yet in the military world. And I hope that's something that does happen, because I think that is what's required to accelerate design and be able to pivot and say requirements have changed. We figured out that something in the field operates differently and we got to change that design. The level of adaptation we're watching in Ukraine, for example, of how quickly those drones are evolving is immense. That is the level of agility that we need to replicate somehow here in the peacetime, because someday we will want that agility ourselves.
I love that. And to tie it back, so Crossing the Valley, this show is really about companies and capabilities that start as small pilots, small experiments, and then scale up over time to be something that actually impacts how a user does the mission. And so, folks working with Macrofab might be, maybe a company has a proof of concept. Maybe they have an initial, or they have a part that has been manufactured a certain way. They want to change that. They want to adapt a product or a capability from something that is commercially viable to something that's defense viable. They come to you all to say, hey, we need to make these modifications to get this defense ready. What I'd love to understand, Misha, is why, how do you all differentiate versus a company kind of creating their own production facility or going to any of the other options available? And how do you all support companies that are on that journey from small scale proof of concept to really scale capability?
With any company that serves either the hardware world, electronics, or any sort of systems that require building plastics or metals, there's really two types of companies. There are some that are purely virtual, and there's some that are very physical, and we are both. I think our approach is to be realistic and assume that, look, nobody but engineers in a building getting their hands on a product and be able to pivot that design, alter that design. So when you work with us, you get both. You get the software behind it, but ultimately, a lot of it is done in the lab. And we have engineers that work with customers to change their designs, adopt them to the requirements of the defense world, and be able to iterate through those designs very quickly. And the scaling functions happens in factories all across the country, as you mentioned. So we really make sure to stage the right part of the project in the right place. But at a most basic level, when it comes time, we literally have people coming down to our facility in Houston. It's an ITAR certified facility, so we can build a range of products for the defense industry. So they know that even though they may have been building something for the commercial world, the very same company can flip a switch and say the way it works in our facility is sometimes we run ITAR jobs and we flip the lights. Everybody knows that we're in ITAR mode now, and all of a sudden things become controlled, and we are now in the physical world changing that design or changing that production run to be ready for the defense industry.
That's a really interesting direction to go. Folks, listeners may know ITAR, International Traffic in Arms Regulations, basically determines what goods can be exported from the United States that have some sort of dual use or military application. And Misha, from a manufacturing standpoint, maybe take our listeners through, one, how are determinations around ITAR restrictions made? And then why is it so important to have an ITAR compliant manufacturing facility? What does that even mean? What did you all have to do to get that certification?
There's a number of compliance standards that in the aerospace world, there's AS8100, for example, but there's a range of, there's DFAR compliance, right? There's a range of standards that manufacturers are expected to adhere to. And this is typical, right? It could be a startup, right? It could be a commercial entity that all of a sudden wants to sell to the defense industry, and they find themselves in the alphabet soup of regulations they never heard of. Now, what people will be surprised by is that most of the time, there are a lot of factories out there that understand those regulations. They have to have standard controls in place in order to meet those regulations. So Macrofab as a company, part of what we do is help them demystify that alphabet soup and just help them understand, here's what it means. When you say you're going to go bid on a contract and you're going to try to take your commercial product, adopt it for the defense industry, they're going to have certain requirements. Here's how we're going to help you make that happen. We are ourselves already compliant. When the rubber meets the road and what it specifically means, ITAR is really fundamentally all about export controls. It's all about making sure that, especially munitions, but really any components that could be used in building munitions, if they're built in the United States, they should be going to places that are authorized by the United States. The last thing the U.S. government wants is for U.S. technology to end up in the wrong hands being used for wrong purposes. So that is what the ITAR complex is all about. It's all about making sure that when you do something, it does not inadvertently find itself into systems that are being built in Iran, being built in North Korea. And I think for the most part, the system works reasonably well. There's a lot of controls around it. Specifically, what needs to happen is that the people that are building these products need to be, in most cases, U.S. citizens. There's got to be very tight control over the design data, because what you don't want is for a supply chain team somewhere say, great, I'm going to go build this product, and where I usually build it is in South Korea. That would certainly fall outside of bounds of what ITAR regime allows. So everybody in that chain, everybody that handles materials, everybody that handles manufacturing, everybody that handles quality is somebody who should be vetted. In most cases, again, they should be U.S. citizens. It doesn't mean that every job those factories are going to run is going to be an ITAR job. There should be visual identification about what an ITAR job is running, because there should be no non-U.S. citizens on the floor. Again, you don't want somebody who is unauthorized to be on the floor and be able to swipe something out or introduce, part of the manufacturing process. At some point, firmware has to get burned onto chips, which is essentially software running on these products. If I was to go break into any system out there, that would be a perfect point for me to introduce malicious software, right? If I can get into a factory and burn that directly into the device while it's being manufactured, that is the way products get hacked. So part of the defense regulations, making sure that never happens, right? So it's a very tightly controlled environment. Everything's got to be time-stamped. Records have to be kept for over 10 years. So it is a pain, but it's worth it. There's a reason why we do all this. And by the way, this is also why we're not going to be as nimble as a country at war like Ukraine. They're not following these regulations right now. In the U.S., we have to do things the right way, but doing it quickly and doing it without friction is what's required in order to move fast. Right.
Yeah, no, speed and certainly necessity trumps compliance. Misha, it's a great overview of the process and why it matters. What I was struck. We had a conversation this past week about what elements of a supply chain really ought to be subject to these sorts of regulations versus ones where you think, hey, we might be over-regulated. I know, for many years, there have been conversations about overclassification in the U.S. federal government. And even dating back to, the SR-71 Blackbird, the CIA set up thousands of front companies. The titanium in that Blackbird was sourced from Russia and done by CIA front companies around the world. And so at some level, it's, the titanium maybe wasn't a risk, or maybe it would have been if they knew who they were selling to, but that was okay. What sorts of things, do you think it makes sense? And you've alluded to some of this around software, but what's kind of, in your mind, the defining line for the types of technologies that really require this level of restriction regulation versus the ones that are, less kind of sensitive?
I may have an unusual view on this, and partly is because I've only been in the manufacturing industry for the last 5 years. Most of my career was actually in cybersecurity, and I spent a lot of my time certainly working with in a defense world with cybersecurity matters, but also done a number of compliance audits. I would actually go the other way, right? I think controls are a good thing. I think executing controls quickly is even better. Making them frictionless and really built into your entire infrastructure is what we should be heading towards, right? The reason why they're onerous and the reason why they're complex is because I think the world is still too physical. And I think a lot of these things require a lot of work to get done, but they shouldn't. In fact, I think a lot of people in the defense industry would be surprised at the degree to which systems that are built from the ground up, that are super modern, and are digitally native, built on top of modern APIs, how much of these requirements are baked into them by definition, right? These traceability concepts that are being grafted onto the physical world, that is very typical in Amazon Web Services or Azure, for example. That is the way large cloud operators work. A lot of things that we get taken for granted in the software world, for example, are missing in a physical world. And I give you one very simple example, right? Any software organization out there, the startups, it could be large companies, they're very good at knowing what changed, right? They have built systems that are checkpointed at every stage of the process. There are automated gates required for testing. And these teams are instructed to where, look, you can build software very quickly. You can release software multiple times a day. But the price of that is that you got to automate all of your test gates, and all of your changes have to be checkpointed and tracked so we can trace back to where the fault happened, right? They move quickly by automating all of this onerous infrastructure. We should be doing the exact same thing in the physical world. So I would advocate for more controls, but more software enablement around those controls. Look, at this point, it should be trivial for us to store traceability data infinitely. Why is that hard, right? What's hard is that the amount of investment in our manufacturing companies is so low that they don't have access to the most modern IT systems. That's the real problem. I think a lot of the problems that we have in terms of friction and how long it takes to get things done is because the manufacturing sector has been starved of resources and managed down to a very low margin operation. Guess what happens in low margin operations? They cut corners on technology and anything that isn't essential, so they don't modernize nearly as fast.
Yeah, the call for more restriction or more compliance or more controls, let's use a better word, is interesting. It's actually coming today, earlier today, the news that DoD released a memo on ATO reciprocity for the first time, at scale across the department, saying if you have an authorization to operate a piece of software in one service or in one environment, that will generally now be accepted in another. It's a big deal. We'll see what happens. Obviously, like with all things, devil's in the details. But for many years, this is another example of kind of a compliance-based exercise with a risk mitigation framework that was many would accuse of just being a box-checking exercise that was more about security theater than security in practice. And I think what you're talking about is really around how do we automate some of these controls so that we know what's going on and that it's second nature as opposed to making this an onerous, compliant, time-intensive exercise?
Look, it's all possible. The best software engineers should be rotating out of the, look, we have plenty of social media networks out there. We don't need anymore, right? We have all the cloud companies we need, right? The investment should be rotating out of that world and into the defense industry. I think is quite important. I think that's undeniable. To me, it's fascinating that one of the biggest popular misconceptions is that we spend a lot of time, a lot of money on our defense budget, and people continuously bring out the tropes about $10,000 toilet seats and $100,000 hammers. There was just recently, somebody held up a bag of bushings in a congressional hearing, and everybody thinks that we're just overspending wildly on our defense budgets. They're near an all-time low compared to GDP. So look, we have the world's largest. Really, for the size and scale of it, it is a fast-growing economy. We have most to lose. It stands to reason that we should spend the most to protect it as well. All of this costs money, right? There's a reason why the best software engineers live in Silicon Valley and work on what I believe sometimes are trivial projects. People are paying them $500,000 a year to do that, right? We simply have to find ways to attract that kind of talent to the defense ecosystem as well.
The talent conversation is one that's certainly near and dear to my heart. And I think it's a great segue to a little bit of your story, Misha, because as you said, manufacturing is not the area that you've spent most of your career. I'm curious, tell us, how did your time at AlertLogic, first of all, what were you doing at AlertLogic, and how did that lead you to this position today?
Things happen serendipitously. I think a lot of it is accidental. I certainly didn't plan it. We started AlertLogic back in 2002. Right. As a cybersecurity company at the time, we didn't know what it was, but it turned out that what we were doing was software as a service. So we were one of the very first software as a service based cybersecurity companies. Had a great time. We built it to about 700 employees, exited to a private equity firm, set a fantastic run there. We built a lot of products that were first to market. But what that ended up giving me is a front row seat into how the industry changes, because in those days, it was all about telecom firms struggling to become internet firms. 10 years later, we saw a major pivot from data centers to cloud. We were the first company to secure cloud environments. We're at the very first Amazon reInvent conference. We're one of the first cybersecurity products in the Amazon world. So, manufacturing is one of those areas that is going through that kind of transformation. I think we're in the very early stages of digitizing a very old legacy industry. And I always found it intellectually fascinating, but I certainly wouldn't have thought of myself as ever diving into this area. But one of our co-founders, really the guy that was I was the security expert. He was a software engineer. He was our chief architect. And at one point, he literally showed up in my office and said, I quit. I've been building this product in my spare time, and I have 1,000 pre-orders for it. And I guess I got to go start this robotics company. And this was a fascinating product. It was a motion control system for video, right? So these time-lapse videos, actually, his product was used in House of Cards, right? That initial opening sequence, that was the rig that they used. It used to be, $50,000 to $100,000. He built them as an open source project, and people just paid him $5,000 each for these robotics systems. So he built that product, and 3 years later sold it, and then started Macrofab because he realized that the manufacturing industry is just hopelessly broken. He wanted it to be software enabled. So he took all of his lessons from the way we built software, the way that we saw cloud environment evolve, and founded Macrofab. By then, I had a little bit of money to invest, so I invested into his company, even though I thought he was insane. I was like, look, I thought all manufacturing happens in China. I didn't realize that, a good 1/5 of electronics is built in the United States and North America. I didn't realize that. So to me, the only reason I dived into it is because he said it was a good idea and I trusted him blindly. 5 years ago, I decided, this is something that is important. We are perpetually early to the party. So I think this whole world is going to get turned upside down through digital technologies. I think we have a shot at being one of the most important companies in the space. So that's how I ended up here. It was time to go do something new, and manufacturing was next.
It's a really neat story. So somebody who was working for you, started a new company, brought you kind of along. That's a cool the world works in mysterious ways, and it does feel like,
I think in a lot of startups, you got to be authentically a person that actually experiences the pain in order to start a company. I spent a number of my years in the Techstars ecosystem helping mentor companies, and I think they thought I was helping them, but they were helping me. Because when you start one company, you really don't know anything. You have a lot of experience with one company. But I think a company startup process is fascinating. It comes from an innate, blind, in some cases, foolish belief that something has to exist. And you're the person that has to go build it. And every time you do that, that is some kind of magic, right? When it works, it's really amazing to watch it go from startup stage to fruition. But one of my biggest concerns was, 16 years in a cybersecurity company you eventually stop being a security guy and you become an executive. And executives don't really know a whole lot, right? So I needed to attach myself to something where somebody saw a really painful problem. So he was the one. He was he built a robotics company, felt the pain, built a company around it. It's something I totally identify with.
I love that idea that, hey, I didn't want to become an executive. I want to be a startup guy. And so I had to find a way to attach myself to a problem. You hear, Misha, this is very little to do with even the specific company, but you hear a lot about people who fall in love with a product, fall in love with their own product. And I think the greats fall in love with a problem. And just hearing you say, hey, look, I need to go chase a problem. I need to kind of a next challenge is really neat. And I think that for those who are listening, who are starting, companies or pursue, which is really kind of a crazy thing to do, right? I remember professor and mentor of mine who said starting a company is literally it should be your course of last resort. You really should only start a company if there isn't a job in the world or a function or an organization that you can where you can have the impact you want to have, where you can work on the problems you want to work on. Starting a company is not for the faint-hearted as much as we glorify it through.
It's funny you say that because that's exactly the reason why we started Other Logic. I didn't think I was ready, so I went to try to get a job as a product manager in a cybersecurity company, and I couldn't get the job. So there was only one thing left to do is go do it yourself.
Build it yourself. Yeah. Don't take no for an answer. I think that's a really important lesson. And certainly in this market where you hear a lot of no, it's an interesting one too.
That pain point is super important. I mentored a lot of Techstars companies. Every one of them got advice to pivot, right? They go in there to talk to these mentors, and the mentors immediately say, that doesn't make sense to me. You should do something else. Here's what I think you should pivot to. It was really fashionable to pivot at the time. And my advice to them always was, do not listen to these people. When they say pivot, that means they don't understand the pain. They don't understand why you started this company in the first place. Pivot means you're pivoting to something they think is a big deal. But frankly, they don't know anything. Like when you're already successful, you're probably at the height of your ignorance. You're no longer living in a real world. So think back to what caused you to start this thing in the first place. That is the only thing that truly matters. Now, the business model might be different, but the pain point, do not pivot away from there because you will definitely fail.
The tenacity to keep going is definitely something that sets apart, those who succeed and those who don't. And, I want to just talk for a minute because we glossed over it a little bit, Misha, but, you're dealing with a customer base that is working on some of the most sensitive programs in the world. Some of the most important capabilities, the most highly guarded capabilities. And so in that context, trust is so important. Trust is such a currency. And as a newer company, when you all first started, when you came out of this space, how did you earn the trust to have them, try you all to manufacture these components or these entire solutions for high priority, high profile, highly sensitive projects?
We may have and this isn't going to be useful to anybody, unfortunately, but we may have an unfair advantage in that regard because we come from the cybersecurity industry. And I think we understand what privacy means, what the need for data security means. So when we go to the most sensitive environments and we tell them that, look, we know how to safeguard your data better than anybody else out there. We have years of experience doing that. And I'm not sure if that's relatable experience to anybody else. But look, that's an example of where you got to use your natural gifts in any situation, right? So, but you're absolutely right. I think it's difficult to go transfer that trust from one place to another. I think partners, and especially people that have that credibility, are incredibly important. A lot of times when I think about the most sensitive projects we work on, we don't necessarily, we're still, to be honest, we're still a little bit too young to go directly into some of the prime programs and bid on them. We bid through partners that understand the defense ecosystem. And those partners realize that not only are we reliable and one of the most modern manufacturing companies out there, but they've assessed our technical abilities and they'll be more successful with us. But I think working with partners that actually understand that world, I think, is essential. A lot of it is just understanding the pure just need for privacy and confidentiality. That's one of the most important things. And I think a lot of people are ignorant to that, right? They don't understand that controls are there for a good reason. And what you should be doing is not fighting them, but actually implementing them gracefully with minimal friction.
Partnerships are a theme. It's one of the themes I love to tease out on this show, because it is really tempting, especially when you're doing something new. When someone doesn't get on board, you say, "We'll go it alone. We'll do it without you." In this market in particular, that manifests often as a desire to bash the primes, the incumbents, the large companies that have been at it for a long time. The reality is they still supply the vast majority of capability. They're incredibly, effective at many of some of the things that they do, less effective at others. They're not going away. At least not anytime soon. And so for startups or for companies new onto the scene, figuring out how to create win-win partnerships where you align incentives with them. And it's not easy because it's not always a complete alignment, but when you can crack that nut, that seems to be where a lot of the magic happens. I'm curious how you all were able to align incentives with some of these larger incumbents.
Look, a lot of it is actually pretty simple. It's commercial in nature. And once you cross the threshold of capability, right, you got to know what you're doing and you got to have a good enough team and technology to be reliable. But beyond that point, believe it or not, it's actually commercial, right? Somehow our advanced technology in manufacturing doesn't actually mean anything if it doesn't enable somebody to do something they couldn't do before. Otherwise, it's just interesting, but not relevant. A lot of it comes down to finding ways for them to make money in places where they would have otherwise lost money or been unable to win a contract. So what we look for maniacally are just ways where our advantage could be asymmetric and can bring something to a bid that isn't previously possible. And I think this is one of the areas where I think the government can do a better job, is matchmaking some of the most innovative companies out there with the companies that actually know how to work with the government, have that expertise. I haven't seen a whole lot of that. There's some programs out there that ebb and flow. Sometimes they get canceled. There is not a very reliable pipeline that takes all the innovation out of the startup world and matches that, especially with primes, right? I think primes struggle to understand how this ecosystem works. So I think these incubation programs and I think these ecosystem programs can be very effective. I haven't seen a whole lot that are on the ground yet.
No, I think that's it's a fair point. There was some recent research about the amount of money that the Department of Defense spends on assistance programs to startups each year. The vast majority, obviously, being in research and development style programs, and frankly, not producing quite what you would hope for the amount of money that's been spent. Misha, I know as we're kind of reaching the latter part of this conversation, I'd love to just turn to the future. Manufacturing right now seems like it's in the news every week. There's a ton of companies raising money to get at different parts of whether it's work instructions, whether it's automation in factories, whether it's humanoid robots. It just seems like manufacturing is having a moment. And I'm curious, as you look out as someone who's been here since before it was cool a few years ago, what do you see as the future for Macrofab and then for the industry itself?
I blindly believe that it's going to be not just digitized, but much more agile than we see right now. And I think some of the headlines we're seeing now, these are imminently solvable problems. We're having trouble manufacturing artillery shells. That is a solvable problem. There's a reason why we can't scale up that production. And it's frankly better to know now than know later. And to give you one quick example of the level of digitization that I think is missing, the reason I sound like a broken record about this is because the very notion of having a design that's digitized and can be portable, can be put into any factory out there, it's missing right now, but it would also be transformational. That's one of the essential building blocks of building resilient systems. That is how cloud environments work, right? When you have a cloud-based virtual data center, one of the most basic things software developers do is just exercise the ability to go destroy a data center and then set it up again within, in less than an hour, right? Everything has to work. It's got to be script driven and it's got to be able to get stood up. Let's say you want 8 data centers. You got to be able to exercise that and make that work. We should be running the very same war games in the manufacturing world, right? And I think the defense ecosystem should mandate that. That should say, let's do a tabletop and let's walk through a supply chain resilience exercise. Let's step through a scale function and see how we go 10x on something that we're building right now that is really difficult. I would venture a guess that would reveal massive number of breakpoints. I think in the future, these problems are going to be solved. I think it's inconceivable to me that it's going to work the way it does right now. It may take longer. My horizon is, I think 10 years from now, it's going to be unrecognizable, but I have no idea, to be honest. I don't know how long it's going to take, but it is going to be software driven. And to give you a practical example of something that should already be software driven, a couple of years ago, we probably already forgotten about this, but for a while, it was really difficult and essential to build ventilators. The world went crazy. We needed nothing but ventilators. It was really amazing to watch how our frameworks designed for World War II were working in that paradigm. I think there was a Ford factory ordered to go build ventilators. So somebody took a design that was built in a smaller factory, put it into a shutdown automotive plant at Ford, and they said, go build a lot more of these. What was their next step? There were 3,000 parts in that ventilator, and they proceeded to 3D scan them because the design files weren't available. Nobody remembered where the STL files for the stuff was. So nobody could just say, look, we got a package of all the electronics, all the mechanical parts. We can 3D print the first 10,000 units while we're building the molds, and we can go build this at scale. They couldn't even get to that point. They had to literally 3D scan every single component in that ventilator. And by the time they were done, we didn't need ventilators anymore. Look, that's an example of how the builds that were built a long time ago were maybe successful in replicating tanks, but they're not going to be successful in replicating digital systems. So that's an example where software could be a huge accelerator. I think 10 years from now, that is the way manufacturing is going to work. I personally believe the government has to have a big role in pushing this forward. And I just came back from China, never been there before, so lots of opinions, never seen it on the ground. The amount of government support for how they want the manufacturing system to work, right, is just night and day between U.S. and China, right? And I'm not advocating for us to become a centrally planned economy. I was born in Soviet Union, so that would be the last person to recommend that. But I do think we've kind of lost sight of a healthy, productive partnership between the private sector and the public sector. I think we've forgotten how the Silicon Valley was born. I think we've forgotten what it's like to work collaboratively with the government, because sometimes the resources required can only come from one place.
I think that's a hard-hitting but fair assessment. And I guess, Misha, if you were to turn around and say, well, give us some optimism. What are you seeing now? Are we starting to address these issues? Do you have kind of reason for hope here, or is it all lost?
Actually, I'm surprised it's going as well as it is, because I think there are a lot of elements that I think we're seeing right now that is getting lost when people get political and start arguing about this administration or that administration. All I know is that now we're going on a second consecutive president, and the two presidents couldn't be more different from each other. These are polar opposites, but I think their economic policy is remarkably similar. I think I'm not a massive fan of tariffs, but I think that they have their role as a mechanism in a trade policy. I think we are consistently tightening up the screws about what's acceptable and what's not, what constitutes free trade and what is dumping and anti-competitive practices. I don't know who's going to be the next president. I'm not sure if it matters. I think the train has left the station, and we're going to keep building more and more sensible policy. I think even things like forcing the divestiture of TikTok is an indication of things that were bantered around as a crazy idea, now understood as something that we may have to do if we are to take security seriously, right? I think that's the right step. And I think we need to understand, and this is not about being anti-China in any way. I think it was an amazing place. I think it is an amazing place. They do amazing things. It doesn't mean that I would let that technology run rampant in the U.S. without any sort of control. And I think same goes for any supply chain, including, especially obviously the defense supply chains. right? Certain amount of our supply chains should be domestic. Certain number of them should be in North America. I think North America is a much more defensible continent than having to rely even on Europe, right? So I think there should be top to bottom industrial policy and supply chain policy that really forces us to rethink how all of this works, because I think pure business rules lead us down a different way, and that's pure cost optimization. We know what that looks like. It's a very global supply chain system with giant container ships moving goods from one place to another, and nothing about that will ever be resilient. The resilience requirements have to come from the government, I believe.
I think we leave it there, Misha. I really appreciate your time and your insight, and I think you have a bunch of unique perspectives and just an interesting way of looking at this industry. If folks are interested in learning more about you or more about Macrofab, maybe they want to get involved, maybe they want to come work for you guys down in Houston, where should they go?
Not just in Houston, we have a facility in Guadalajara in Mexico as well. And now talking to more and more parties about bringing our model internationally through partnerships with companies around the world. So we may be in Asia, maybe in the Middle East, and maybe in China at some point. But macrofab.com, and it's a common misspelling. It's not microfab, it's macrofab. It's the bigger version of it.
The big fab.
Yeah. We have a great podcast called The Circuit Break. It is a couple of electronics engineers talking about electronics engineering. I've only been on it twice because I'm only there as a cybersecurity expert. There's no suits allowed. So it's usually interesting topics. I think if you're in the electronics world, it's something you should definitely listen to. But we certainly love people to join our team. This is a mission-driven organization. There's a lot of people here that believe that the world of manufacturing is going to be different. They could be doing something else. They could be selling software as a service and building automotive products, but they believe that doing this is more important. So we're always looking for somebody who is obsessed with what we're doing.
Looking for obsessed people. If you're obsessed, Misha wants to talk to you. Misha, thank you for your time. This was fantastic. Thank you all for tuning in, and we'll see you next time on Crossing the Valley.
Noah, let's check in again soon. Thank you.